Good morning, mathematicians. Today we are going to be going further in our unit circle. In order to do that, we are going to take a flashback to Common Core geometry and think back to your trig identities, sine, cosine, and tangent. But today we're only going to focus on sine and cosine. We're going to find out what those definitions are of sine and cosine, and then we're going to use them to help us calculate angles and relate it to our unit circle. So first thing I want you guys to do is look at the two do nows that I have here, the two examples. I have two right triangles here. Recall that I know that they're right triangles because I have that symbol right there inside of them. Notice I have all of my sides here labeled for me, so I don't even have to worry about Pythagorean theorem or anything like that. For A, I want to find out what is sine C equal to, and for B, I want to know what cosine A is equal to. So if you think back to that geometry acronym, SOHCAHTOA, that is going to help you be very successful in today's lesson. So since I'm asking you for your first triangle there to find sine C, I'm only going to focus in on the SO part of it. And a reminder that the S is standing for sine, the O is standing for opposite, and the H is standing for hypotenuse. So your sine, anytime I'm talking about sine of an angle, I'm always going to find that by using the opposite side over your hypotenuse. And that will always be the case. So for this example, since I'm asking you about sine C, I'm going to find sine C, or angle C, in my triangle. And then I'm going to follow exactly what it says. I'm looking at the side that's opposite that angle, which is going to leave me with 21. And that's all over my hypotenuse. Well, reminder, your hypotenuse is the largest side on your triangle. So if I'm looking at my triangle here, the largest side that I see is 29. So sine C is just equal to 21 over 29. Your final answer right there. Your next example here, I'm talking about cosine. So I want to focus on the cob part, which is standing for adjacent, the side that is adjacent or next to, because that's what that means, over your hypotenuse again. So here I want to find angle A in my triangle, which is going to be that right there. And the side that's next to it, that leaves me with that length there of 30. And over my hypotenuse, well, again, my largest side here is going to be 50. So in this case, cosine A is just defined as 30 over 50. You guys use this whole process in Common Core geometry to help you find what the measure of an angle is. You used it to help you find missing sides if you wanted to. There's all different ways that you explored it. But you needed to make sure that it was always a right triangle that was given to you. Otherwise, those laws did not apply. Today, we're going to use SOHCAHTOA in order to explore our unit circle. So here I have our unit circle. You guys already labeled the coordinates. You did all of that last week, which was really good. I know that right now you might be thinking, how am I supposed to know that this is the unit circle when all I see here is x comma y, theta, and a side of 1, or my hypotenuse, we can use better vocabulary, as 1. And that's exactly how you know it's a unit circle. Since you have your hypotenuse here labeled as 1, that automatically means that that's your unit circle. Remember, we said the definition, it has a radius equal to 1. Well, that's your radius of 1 right there. This also has a length of 1. That also does. All of those from the center. So that's how you know it's your unit circle. So I want to use my unit circle to find, giving the right triangle shown, an expression for sine of theta. So I have that over here. I want to know, what is sine theta, in this case, going to be equal to? So I have theta in my triangle there. And I labeled the point x comma y. I did that because I don't know what this angle is. I didn't tell you it was 30 degrees. I didn't tell you it was 60 degrees. I'm just saying it's some angle inside your triangle. So since that's the case, I don't know what it's going to be. We're just going to do the same process that we did in our do now. I know that sine is defined by your opposite side over your hypotenuse. So if I'm looking at my triangle here, I'm going opposite. Well, I don't know what that length is. That's what you might be thinking. Like, it doesn't say. Well, that's so silly of you to think, because I know that this is just some ordered pair. If I change this, that point there, to 3, 4, you tell me, oh, my y value is 4. If I changed it to, I don't know, 2, 7, you tell me, oh, my opposite side there is 7. That's my y value. So don't get confused because it's x, y. So if I'm telling you I want the side that is opposite, well, I want to know what is that length there. And that's your y value, or your y coordinate there. And my hypotenuse, well, my hypotenuse is already labeled, so that's going to be equal to 1. So sine theta is equal to your y value, your y coordinate, over 1. Well, what does that really mean? Well, we can simplify that and just say that sine theta is equal to your y value. And this is a huge definition that you guys just discovered here. So sine of theta is always going to be equal to your y value in your coordinate. You'll see what that means later, but it's always going to be your y value. And you just discovered that right through this analysis right there. And if we look back on your paper here, I'm now asking you, okay, well, let's figure out what is cosine of theta equal to, giving the same diagram. So cosine theta, well, if I'm thinking SOHCAHTOA, I know that that stands for my adjacent side over my hypotenuse. So I'm looking from theta again, but I'm not going opposite anymore because I'm talking about the side that's adjacent. So I'm looking at the side that's next to it, that length there. And again, you might be thinking, like, I don't see a value for that length. Well, it's the same idea as before. If I change this ordered pair to 3, 4, you would know that your x value, that length there, is 3. That's what it's reading. If I changed it to 2, 4, you would know, oh, my length there is 2 because that's my x value. So when I'm talking about the side that's adjacent for any ordered pair, well, that's just going to be my x value, or your x coordinate. And again, over your hypotenuse, well, my hypotenuse is equal to 1. So you have cosine theta is equal to your x value over 1. Well, again, what is that equal to? That's just telling you that cosine theta is equal to x, or your x coordinates. And that will always, always, always be the case. So you guys just uncovered something crazy cool that you can fill out right here. So we can now conclude that sine theta is equal to your y value, or your y coordinates, on your unit circle. And cosine theta is equal to your x value, or your x coordinate, on your unit circle. So fill that in for me. And then I want to go ahead and use our unit circle from our last class. Remember, I have this modeled on a anchor chart in our classroom tab. So I want to fill this out with our definitions of sine and cosine. So I just have cosine, sine written here, and I have theta. So theta is representing your different angles of your unit circle. So if I'm talking about 0 degrees, I want to know what is cosine equal to. And you might be thinking, like, what does that mean? Well, again, cosine is just standing for your x value. I'm going to copy this chart down on my whiteboard so we have it. So since cosine is equal to your x value, you should be looking at your unit circle and seeing what is my x value at 0. 30, 45, 60, 90. Okay. So if I actually go ahead and looked at my unit circle, which I can pull up for us, and I said to you, okay, like what is this ordered pair here on your unit circle? Well, we already did that last time. We knew that that was your radius of 1, 0. That's what that ordered pair there is. But I want to know now, what is cosine? Reminder, cosine is only talking about your x value. So my x value of this ordered pair is 1. So I'm just going to write a 1 there. Now I'm saying, what is my sine value of that unit circle at that specific point? Oh, my sine value, that's my y. So that's going to be 0. Okay. So now I want to look at, okay, at 30 degrees. So if you guys go ahead in the classroom tab, I just pulled this up here, or in your notes, I'm looking at 30 degrees. I want to know what is cosine. Well, again, cosine is just my x value. So that's going to be equal to the square root of 3 divided by 2. My sine at 30 degrees is going to be equal to 1/2. 45 degrees, same process. Square root of 2 over 2, that's my x value. Square root of 2 over 2, that's also my y value in this case. Okay. 60 degrees. Well, cosine, what is my x value there? 1/2. What is my y value at that ordered pair? Square root of 3 divided by 2 and 0, 1. All right, that's your table. You just outlined cosine and sine out of all of those key angles that you have defined there. Please, if you have questions or concerns, go back and pause the video and rewatch it. But all you did was label your x values, and I would write that for yourself, and your y values. Okay. Your next table here is telling you something very important. You're going to discover something very important. And I'm talking about your different quadrants, your first quadrant, second quadrant, third quadrant, fourth quadrant. I want to know, like, is sine going to be positive or negative in your first quadrant? Is it going to be positive or negative in your second quadrant? So on and so forth. So since that's the case, I can copy this down here. I have sine and cosine, quadrant 1, 2, 3, and 4. So are your y values positive in the first quadrant? That's really what this is asking you. And you should be thinking, yes, everything in my first quadrant is positive. Oh, since everything is positive, that also means my x values are positive. Looking at my second quadrant here, are my y values, is sine positive? Yes, my y values are still positive. So I can have that there. Cosine, are your x values positive in your second quadrant? No, they are negative. Third quadrant, yes, everything is negative. Fourth quadrant, over here, okay, my x values are positive. Since my x values are positive, again, that means cosine is positive, and your y value is negative. There is an acronym to help you remember, like, what is positive and what is negative. And it is called All Students Take Calculus. And this tells you which values are positive in that quadrant. So all is in your first quadrant, representing everything is positive. Sine is in your second quadrant, which is saying only your sine value, only your y value is positive in that quadrant. Tangent, we'll go through that, but only tangent is positive in your third quadrant. And your fourth quadrant there, only your x value or only cosine is positive. Okay? So this is a lot. It's definitely confusing. I want you guys to go ahead and practice with the remaining examples. I'm going to give you guys different angles and I'm going to ask you to evaluate them. So cosine 240, I want to basically know, I'm saying to you, hey, what is your x value at 240 degrees? All right, go through, try your best, and we'll have a Google Meet on Wednesday. Have fun.